Corporate Finance Excel Practice Problem. In this presentation, we're going to work a practice problem in Excel related to the present value calculation, often abbreviated as PV. We're going to do multiple formats of the present value calculation. One, using a formula. Two, we will calculate it in Excel using a function. And then three, we will calculate present value using tables. You can also use a financial calculator, calculate present value. We will not do that here, but it will be similar to the function used in Excel, which we will demonstrate. Get ready, it's time to take your chance with corporate finance. Here we are in Excel. We have our information on the left-hand side. We're going to put that into the blue area into our worksheet on the right-hand side. We're going to be calculating the present value using multiple different formats. Notice that we do have 3 tabs down below. If you're working along with an Excel worksheet we have provided, you might have 6 tabs, 3 with the answers to them, 3 with the practice worksheets we have here. If I go to the second tab on the practice 2 worksheet, note that it's going to be similar layout, different numbers. Practice 3, same thing, similar layout, different numbers. Let's go back to practice 1. So what we're going to be doing is calculating the present value. That means we're taking some amount of money that we're having in the future and bringing it back to today's dollars, to think about it in terms of today's dollars. Now note there's different scenarios we might have in this. Oftentimes we're thinking about money that we might be spending in the future and thinking about, well, how much is that worth, basically, if I'm looking at future money that's being spent as compared to current money that's being spent, or we might be receiving money at some point in the future. That's kind of the scenario that's easiest to think about. So let's imagine a situation where we're going to be receiving some amount of money in the future. In this case, we're going to say we're going to get $10,000, but not for 12 years. We're not going to get it for 12 years. So then we got to think of, all right, well, I know that there's time value of money, which includes at least 2 factors. One, the fact that there's going to be inflation, most likely, meaning the value of the dollar itself is not stable. It will typically go down. Now, the level of inflation right now is pretty low. It could jump, sometimes and whatnot. But it's going to be the inflation's around 1 to 3% is what in the U.S. they kind of shoot for within inflation. You've got that factor. But you also have the factor of, well, if I have the dollar today, then I could do something with the dollar. I can put it somewhere else. If I have the $10,000 now, then at least I can put it in the bank and hopefully make enough money to pay, get the inflation. But I may also be able to use it, consume it, getting value of it for that 12 years that I wouldn't be able to do until at the end of the 12 years. Or I might be able to put it in some type of investment. If I was good about it, then I might be able to make a rate of return that would be higher than the 12%. So that would, then say the 5% or the 3% that would be inflation. So that's what we have to think about. We're going to say, okay, well, if I got $10,000 12 years from now, then I have the opportunity cost of the money that I got to think about, meaning if I had it today, I could be using it in some way. And we have the cost of the money just in terms of the devaluation, typically being the dollar typically goes down in terms of inflation. Inflation means the value of the dollar basically goes down. You can buy less stuff with it. And that's typically the way, the currency will go. So that means that we have to come up with some kind of discount rate to consider those types of things in terms of valuing the dollars today. What's the opportunity cost basically, and what's, the kind of like the devaluation of the dollar going to be considered. And you could think of it in reverse format again. Well, what if I had the money today? What could I do with it? What kind of return might I be able to get with it, to try to think about that discount rate? That discount rate is a little bit confusing of a number to figure. So when you're looking at something in the future, you got to think, okay, I got to bring that down to today's dollars, which means it's going to be worth less in some way, shape, or form because of the time value of money. And then you got to think about, well, what would the discount rate be? And you have to take some of those things into consideration with regards to the discount rate. So we're going to assume a few discount rates. We'll say, okay, 5%. So as a discount rate on our first assumption. So it's going to be a modest, kind of fairly low discount rate or modest type of discount rate. What if we got 12,000 12 years from now? What would be the value of it today if we used a 5% discount rate? We're going to use a formula to do that, Excel, and then we'll use the tables down below. So let's do the formula first. So we're going to go up top in the formula. I'm going to try to break this formula down into basically a table format. So notice what we have. We've got the future value here. So we got the future value times the second component. So future value times 1 over 1 plus r to the n. Now we could multiply this or break this out into multiple formats of a table. You can obviously just put the numbers into the worksheet, into the formula here, and solve it algebraically. I think it's useful to make out the table, because then once you have the table, you can change the numbers here and you can see the parts of the calculations that change within a table format in Excel, which could give you some insights and be useful when you're actually using this in practice. So the first thing I want to note as we break this out in the table is we could see this as, since it's fair value times 1 over 1 plus r to the n, we could see it as the fair value over 1 plus r to the n, because fair value over 1 would times 1 over 1 plus r to the n could be rewritten as the fair value over 1 plus r to the n. So that's kind of how we'll break it out in our formula here. So I'm going to say, all right, let's take these two pieces. I'm going to say we have then the 10,000. I'm going to put this in the outer side. That's going to be the fair value, or you could see that if I put that on the top here, that would be our numerator here. So I'm going to put that on the outside. Then I'm going to do the whole basically denominator, which is going to be 1 plus r to the power of n, which is going to be the number of periods. So I'm just going to say we have 1 plus the rate. The rate is going to be equal to the 5%. I'm going to percentify that cell. Home tab, numbers group, let's percentify it. Underline it, home tab, font group, and underline it. Let's put a subtotal, which is going to be just 1 plus r, let's call it, as the subtotal. This is going to be equal to the sum of these two numbers. I'm then going to format this in a percent, home tab, numbers, percentifying it, and then I'm going to take that and we're going to take it to the power of n. So now we have this number here. We're going to take it to the power of n. And I'll unformat this for now to the power of n. And n is going to be the number of periods, in this case years, so therefore 12. 12 years. Home tab, font group, and underline. And that's going to give us this whole kind of piece. And so that's going to be this bottom half. So I'll move that to the outside. We're going to say this equals the 105 times the power, which is shift 6, which is that caret, not times. Shift 6, so it's the 105 shift 6, and then the 12. So 105% caret the 12, and we get 2. I'm going to then add some decimals, home tab numbers, adding a few decimals here. Let's keep it there, and then that's going to give us the present value. So I'll get the present value, then it's going to be down below, and we will divide this out. So now we've got the numerator and the denominator. So if you imagine rewriting this as future value over 1 plus r. Now we have the future value over 1 plus r to the n. So we'll divide it out. This is going to be equal to the 10,000 divided by that 1.79 and so on. Let's go ahead and add some decimals here. Home tab, numbers, and we'll add a few decimals. So 10,000, 12 years, we're at a discount rate of 5%. We're going to say it's worth that 5,568. Again, it depends greatly on the discount rate that we're going to have in terms of what value that we will be given or will result. Now, if we then say, okay, let me consider like the percentage rate. This is what we're going to use to see the table. So in other words, if I divide it out, the present value divided by the 10,000, this is going to be the percentage of it that we can use to see to compare to this table down below. It's kind of how you would construct the table, which we will see shortly when we do the calculation for a table. Let's go ahead and underline this by going home tab, font group, and underline. I'm going to indent these tabs by selecting them. Home tab, alignment, increase the indenting. Select this one. Home tab, alignment, increase the indenting. All right, now we'll do the same thing with the use of Excel. So there's a couple ways we can do this. We can actually write the formula or enter it saying equals PV, or if we don't know the formulas, then we can go to the formula tab up top to the insert function. We could look up the formula, which is going to be present value, and then we could see if it comes up here. We're looking for present value. They gave us future value. There it is. And it gives you a little name here. So returns the present value of an investment. So we want the PV or present value formula. We'll select that item. Then we get the little dialog box, which is a little bit of added help. We get a nice little helpful thing if we just use the formula, which would look like this, which we'll do in the future. But this dialog box can give you a little added information. So we're going to then say that we have the rate. It's a discount rate, and it's a yearly rate, so we don't need to do anything else to it. The number of periods, that's what PER is. The number of periods is going to be 12, that being the years. The payments, this is where it's tricky, because we're not talking about an annuity and therefore we don't have any payments. We're going to use the same format if we had an annuity or the present value of 1. Therefore, this needs to be 0. I'm just going to put 0 there. And then the future value is going to be the 10,000 we're imagining we're going to get in the 12 years. So that's the future value. It's gray because you wouldn't need the cell if you were talking about an annuity. But if you're talking about the format we're using here, then you need that cell. These 3 would be needed whenever you use this function at all. So I'm going to say OK. And there we have it. I'm going to add some decimals by going to the Home tab, Numbers, adding a few decimals. So there we have it. Same number. We're going to double click on it because I'd like to make it a positive. So I'm going to double click on it, putting a negative before the P, which will basically take the entire thing, multiply times -1. Some people will put the negative some other place in the formula. You can, but I just like doing it this way. I just take the whole thing and then flip the sign on it, which brings it to the positive number. Let's do the same thing with a table. Now, this calculation is the way you'll probably see it in a lot of times when you're using Excel, but notice it hides a lot of the formula of the calculation. So you can't really see the number of years and whatnot as you can if you kind of break out the formula. That's why it might be useful to actually break out the formula in this fashion in Excel so you can change the data up top and see a little bit more detail in terms of what's happening just simply from the formula. But this is going to be very helpful, this present value, when you're doing more complex types of scenarios where you have costs or things that could happen in the future and different discount rates and whatnot. So then we're going to use a table. Table is going to be very useful. It was useful before we had like financial calculators and Excel, because then you can provide this table instead of doing the formula. Now it's very useful for test taking purposes. So classrooms still really like the table because the table can be used when you're taking a test without giving access to a calculator. So it's still in use. You'll still see it. May not be as useful in practice, especially if you have access to a computer or even a phone now, which has financial calculators and even spreadsheets on them. But this is still going to be useful, and it's nice to know how the table is constructed, and you can kind of see how the table would be built here by us doing the calculation. See this number here. This is kind of how you would construct the table. You can do this calculation for each number and construct the table. So the table down below then, we're going to say that we have the rate of the 5% and 12 years. So 5%, 12 years, that's 0.5568. So 0.5568. So let's say 0.5568. That's on the table. Let's format that. Home tab, Numbers, add a few decimals. So there we have it. Underline it. Home tab, Font group, and underline. That's going to give us then our present value calculation being equal to the 10,000 times that decimal 0.5568. Let's add some decimals here. Home tab, Numbers, adding a couple decimals, and there we have it. Notice it's rounded here. I mean, it doesn't have the pennies, so it's not as exact. Why doesn't it have the pennies? Because we took it out to 4 decimal places, whereas over here you can see it keeps going. It's really 0.55684 and so on. So the table being estimated, because if you have an ongoing fraction, the table is going to stop somewhere, and therefore you're going to end up with an estimate with regards to the present value, which should be close enough to what you need, but not exact. Notice that if you are taking tests, they can test you as to what format you are using. If they gave you a table and you didn't use it and instead used a present value in Excel calculation, then they can see that, because they can see that you didn't get the right pennies, that were actually an error, but that's what you would get as a result of the table, which is less exact than using Excel. So it's useful to know those little differences, because again, a test question can ask you specifics that would test whether you did what they asked, even though you might have done it in a more efficient way and gotten a more efficient answer, but they're testing for you to do it. Anyways. So now let's go to the second tab. Same thing, we're going to do the same thing. Now we got 20,000 we're imagining we're receiving after 3 years, discount rate 7%. Remember, that discount rate is the time value of money. How do you get to 7%? What did you get 7%? Well, the opportunity cost of what I could have done with that 20,000 now, like could I have gotten an investment and a return on that investment if I had it today of 7%? That's one way you could think about it. And obviously inflation would be involved just the value of money could be involved with that calculation as well. So that's how you kind of determine the discount rate. There is no set discount rate. No, we don't know because we're projecting into the future. But you can imagine those factors as being, the discount rate, how we would think about what to put as the discount rate. Now I'm going to go back over to the first item here, and I'm going to copy this whole thing. Let's just copy the first half of it. So I'm going to go to the practice problem 1. I don't want to retype in the whole table, so I'm just going to copy this whole thing. Control C, practice problem 2, Control V, and there we have our table. I'll even go over back to practice problem 1 and copy the formatting of all these cells. I'm going to select these cells, Home tab, Clipboard, Format Painter, Practice Sheet 2, and then I'll format these cells. I'm going to move this table down a little bit because it's hiding something down here. Okay. So now let's go ahead and plug our numbers in here. So we're going to, once again, this formula, future value times 1 over 1 plus r to the n can be written as future value over 1 plus r to the n. So I'm going to say future value, or numerator. I'm just going to put on the outside the numerator. Then we've got the denominator 1 plus r to the n. So I'm going to say, all right, let's take the 1, and then the r is the 7%. Let's add them up with the sum function. Equals the sum, gives us 107%, the number of periods now, which is n. So now we did this calculation. We're going to the power of n, which is going to be 3 years in this case. So now we're going to say the inner part to the power of n, which is going to be equal to the 107 caret shift 6, or shift 6 is the caret is the power of n to the power of n, which is 3 years. And there we have it. And so we'll multiply or divide this out now. So it's going to be the 20,000 divided by that number. And that's going to give us then the 16,325. Notice if you end up with something with like these bunch of these little things, then you got to increase the cell. So you have like more room. All right. Then that means that we can also figure out what would the table amount be down here by dividing that out. We can say, well, let's take that number divided by the 20,000. And the table amount down here that we can use to kind of jump there if we were to build the table is this. We'll compare that to what we see on the table when we get to the table calculation. Now we'll do the present value with Excel. So I'm going to say this is going to be the present value. Now this time, let's just use the formula right here. It's a little bit more difficult, but pretty easy. We're just going to say equals PV. PV, there's the present value function. I'll double click on it. And then we got this nice little dialog box that tells you right what you need to put in here. It's very nice. So it says the rate. Rate is going to be the discount rate in this case. That's going to be the 12%. You got to put a comma. So it says once you're done with that, this bolded part, put a comma there. And that takes you to the second part, which is NPER, which is the number of periods, which in our case is 3 years. And so we're going to say, and then it says comma, and then it jumps to the next one, which is payments. Now, payments is the funny one because we're not doing an annuity. That means like if we were doing an annuity thing, but we're not doing an annuity thing. So that's actually 0, or you can just put 2 commas. I often just put a 0 there because it makes me feel like I did something in that area. And then the future value is going to be what we're going to get in the future, but it's in future dollars that we're trying to discount to like today's dollars using the 7% discount rate. So the 20,000, there we have it. Then you could put a bracket to close this thing up. But Excel knows that you probably are going to close it up, so you don't really need to. And so we'll just hit enter, and it doesn't give you an error or anything. It just does it. So then we can add some decimals. Home tab, numbers, add a few decimals. Going to widen this cell so it has room. Okay, so there we have it. Once again, let's make it a positive number. I'm going to double click on it, put a negative before the P, which will basically just flip the sign to a positive number. So there we have it. Let's do it again. Let's do it with the table this time. So we're going to say a table calculation, which will come out to something slightly different. And again, this is how like they might test you like on a test and ask you for the pennies, which are insignificant in real life, but can determine whether or not you use the table like they told you to do on a test question. So now we're going to say that this is going to be the 7% at 3 years, so 7%, 3 years. So we're looking at the 0.8163, 0.8163, so 0.8163. Let's go ahead and format this, home tab, numbers, and add a few decimals, and then underline, And then this is going to be the present value. The present value then calculated as equals 20,000 times that 0.8163. Let's add a few decimals, home tab, number group, add a few decimals. So notice it's a little different here to the calculation than here. Probably not significant for real life purposes, but it's different for test taking purposes. Why is it different? Because we rounded it to 4 decimals on the table, 0.8163. And over here, it's really 0.8163. And if I add, it's 0.81636298 and so on and so forth. All right, let's do it again one more time. Practice 3. So now we're on practice tab 3. Now we got 30,000 that we're going to get in 9 years at a 12% discount rate. So if I got 30,000 9 years from now, 12% discount. Where did the discount rate come from? Well, maybe we think if we had that 30,000 today, we can get a rate of return of 12%. We can get the opportunity cost, what we can do with it today, if we had it, right? That might be one way we can think about the discount rate and the time value of money, the deflation of the dollar. So we're going to say now it's a 12%. So it's a prediction. It's, that's going to be something we have to kind of figure or think about. It's not going to be given. We don't know that for sure. So we might use different scenarios to hedge our risk in the future to try to think about, well, what discount rate would it be for, and what would the outcome be, and so on and so forth, which you can do if you set up your table here. All right, so then let's go back to practice problem 2. Let's copy this whole thing again. So I'm going to copy just the formula, Control C, and let's put that over here, Control V. Then I want to format paint the number amount. Let's take the number amount and format paint it. Go into the Home tab, Clipboard, and use the Format Painter. And then we'll format paint this entire thing. So there we have that. All right, and then let's do our calculation. So we have our formula, present value equals future value times 1 over 1 plus r to the n. It can be reformatted as future value over 1 plus r to the n. So future value, I'm going to put that on the outside, now being 30,000. Now we're on the denominator, 1 plus r. So I'm going to say, all right, that's going to be 1, which I'm just going to type in 1, plus r. So r is the rate. And I'll add them up for a subtotal of 1 plus r. So here's the 1 plus r portion. There it is. Now to n, which is the number of periods, in our case in years, which is 9. And so then I'm going to say, all right, now we'll take it to the power of n. So we got this equals to 112%, shift 6 for the caret, or the power of 9 to the power of 9. And then we're going to say this equals the 30,000 divided by that amount, because now we have the numerator and denominator of fair value and the denominator. So let's go ahead and widen that out so we have enough room for it. We got the 10,818. If we look at it as a percentage of the 30,000, this 10,818, the value after 9 years of the present value, this would be the present value if we had a 12% discount of 30,000 we're going to receive in 9 years. Okay, then we're going to take this divided by the 30,000, and that's going to be the percent that we would basically use to build our table down here, which we'll see when we do our table calculation. Now let's do the Excel calculation. So present value. Let's do this again, just using our formula right here instead of going to the formula box, and the formula's up top. I'm just going to say equals future value. Present value equals PV, and then I'm going to say shift 9 this time, shift 9, putting brackets on. Then we need the rate. It says we need the rate, so I'm going to say that's 12%, and then I'm going to put a comma so it'll go to the next one. So comma, it says NPER, number of periods, that means 9 periods, which is years in our case, comma. Then it's the payment. Once again, we don't have a payment because it's not an annuity, and therefore we typically put 0, comma, or you could just put 2 commas. Let's do that this time. 2 commas means that you kind of skipped something because it wasn't needed right there. And then we're going to go to the future value, which is going to be the 30,000. 30,000. And so there's our formula. So there's the formula. You could close up the bracket, shift 0, but you don't really have to because Excel knows what you mean. And it won't even give you an error if you don't close it up. It'll just do it for you, and that's okay. So that's this number. I'm going to make it a positive, double-clicking on it, putting a 0 before the P, Very useful calculation. This makes projections and complex projections into the future, these formulas, much, much easier, and makes us, able to switch the projections a lot easier, especially when we have more complex projections with different discount rates for different periods and that kind of thing. So then we got the 30,000. Again, let's do the table this time. Table 30,000. The amount from the table, then, if we now say, all right, now we're talking 12%, 12% 9 years. So here's the 12% years, 12% years are 9. So here's 9. That's going to be the 0.3606. 0.3606. So we're at 0.3606. Let's add some decimals. Home tab numbers, adding a few decimals, and then underline, home tab font group underline. That's going to give us our present value. So the present value here is going to be equal to 30,000 times that 0.6306. Let's add a few decimals. Home tab font or number group, add decimals. We're at 10,818. Not exact. Why? Because this is only rounded to 4 digits, 0.3606. And it should really be 0.36061 and so on and so forth from there. So less exact on the table, but useful, probably has what you need for real life, and it has enough difference that you need in order to let a test question test you on those pennies to see whether or not you use what they asked you to use to calculate the present value.